Hi guys, so today we'll be doing the FEMAS 2016 paper. So first question. So now the ln can get cancelled. 4x square. X will only be positive here because ln can't be negative. So it'll only be x equals to 2 by root 3. So now first let's open the brackets. Tan 45 is 1, so we'll just write that. So this is 1 minus tan theta. So it's a plus b and a minus b. So we'll have tan theta plus tan theta will be 2 tan theta. Tan square theta. If here it's 4 tan theta minus 2. Right, 0. So this is the final equation and solving it. So we take tan theta this is the Tasacharya's rule, I think. I don't know what it's called. Also, minus b plus minus root over b square minus 4 ac by 2a. So this is from 0 to 180, right? So there'll only be one answer. 38 plus 2. No, wait, there'll be two answers, I think. 28.7. And 2 minus 3. And the other answer will be 165.4. I think it's always 1 dB, right? Yeah, 1 dB. No other answer. No other answer. So that's number 2. The equation has one positive root. Okay, so since the equation is given, we have x equals to 1 and x equals to 2. So we just put the value of that in the calculator and see what we get. So 1 minus 3 plus 1 minus 4, that's minus 5. And if we have 2 to the power 5, this is 13, I think. That doesn't matter. This is negative and this is positive. And so sign change indicates the presence of a root. So its root is only possible when it's equal to z when there's a sign change. So yeah. So now show that the equation can be rearranged in that form. Okay, so x. So here we can see it's root 3. So we'll keep that on this side for once. And then, wait. Let's just see. 3x cubed minus 4 equals 0. Alright, yeah. So now we divide the whole thing by x squared, I think. Both sides. Gives us x cubed, gives 3x minus 1 plus 4 by x squared. So now we get that. Right. Right, so now part 3. So we have to do iteration up to 4 dp, right? So we take x1 as any value between 1 and 2. So I'm taking 1.5. So I get the value 1.7411. I already put in the calculator, so you have to basically, when you put this, then you get this, and then you put this in the calculator, and then you get that, and then this again in the calculator. That's basically how you have to do this. Until we have to write till 2 dp, so until the 2 dp's match. So we keep doing this. Right, so 2 dp is matching, so we get 1.78. So this is my final answer. Moving on to number 4. The polynomial. Okay, it's 4x cubed plus ax plus 2. So 2x plus 1 is a factor. So we have to find the value of a. So if 2x plus 1 is a factor, x equals to minus half. So we can just substitute the value and find a. So I got a equals to 3. So now we can just factorize it. So there's no remainder. That proves that it's a factor. So now we can factorize that. I don't think we can factorize this further, so it'll be like this only. So this is the answer. Moving on to part B. So solve the inequality p x is greater than 0. Justify your answer. So over here the critical value will be x equals to minus half. because in this one it's x doesn't have a real root, because the discriminant, this is negative, this is negative, so it doesn't have a real root, so it'll only be x equals to minus half. So 2x plus 1 is greater than 0, x is greater than minus half. And you can justify this by putting in a value and checking if it's correct. Number 5. So we have to use the substitution of x equals to root 3 tan theta. So we can see we'll have to substitute the dx if we have to use theta. So this gives us the differentiation of this will be root 3 sec square theta. So dx equals to root 3 sec square theta d theta. And now we can substitute the values. 9 by 3 plus x square will be 3 tan square theta whole square. So since we know that's x square, you have to turn this also into sec square. So 1 plus tan square theta is sec square theta. Over here multiply by 3, so 9 by 3 sec square theta whole square, because there's a whole square here. D, now this time will be in respect with theta, so into root 3 sec square theta d theta, and the limits will also change. So instead of x equals to 0, it will be, we have to put the value in this equation. So theta will be equal to 0, because tan 0 0 into 3 0. And if x is equals to 1, theta will be equal to 30 degrees. So if x is 1, you should put 1 over here, it's 30, which is pi by 6. So wait, this would be 0, so 0 by anything will be 0, so it will be, the value will be substituted with x. So 0 stays 0 and 1 becomes pi by 6. So we can have 0 to pi by 6 of 9 by 3 sec square theta whole square to root 3 sec square theta d theta. So here this will become 9. So 9 will get cancelled, and sec square 1 will get cancelled. So it's root 3 sec square inverses cos square theta d theta 0 to pi by 6. This is the, yeah, see, it's proved. Part 2. Hence find the exact value of I. So I usually change this to cos 2 theta. So since cos 2 theta is 2 cos square theta minus 1, so cos 2 theta plus 1 by 2 is cos square theta. So root 3 by 2 into cos 2 theta plus 1. Integration will be now we'll do upper limit and lower limit. So pi by 3 sine answer root 3 by 4 plus pi by 6. That'll be minus 0 anyway, so it's fine. So that's 3 into 3, 9 plus let's just leave it separate, so it'll be 3 into 3, 9 by 24 plus 2 root 3 pi by 12. 3s are 8, 3s are 3. 4 3s are okay, 6 2 pi. Right. Alright, this will be also 20. Sorry. Over here. So 3 by 8 plus root 3 by 12 pi. Yeah. So we get the answer. Number 6. So dy by dx will be, so this is part, I think, wait, implicit differentiation, yeah. So sine y differentiation is cos y dy dx into ln x plus sine y into 1 by x equals to 1 minus 2 cos y dy by dx. So now just rearranging. So dy by dx. So part 2. Hence find the exact x-coordinate of the point at which the tangent is parallel to x-axis. So if it's parallel to x-axis, dy by dx equals to 0. So 1 minus 1 by x sine y equals to 0. So 1 equals to 1 by x sine y. So sine y equals to x. So now in the place of sine y, we can write x in the equation. So we'll have x ln x equals to x minus 2x. So x is equal to e to the power minus 1. So that's what we have to find, the x coordinate. We can also write it as 1 by e, but yeah. Moving on to number 7. Number 7. Differential equation. So first we have to, in this one, first we have to separate this portion. So we get x into e to the power x into e to the power y. And now we can get the y down. So 1 by e to the power y dy gives x into e to the power x dx. Now we integrate both sides. So this is e to the power minus y dy. And this is x e to the power x. So integration of this will be minus e to the power minus y. And this side will be by parts, so we'll do that separately. So u equals to x, du by dx equals to 1, dv by dx equals to e to the power x, v equals to e to the power x. So uv minus v into du by dx will be x into e to the power x minus e to the power x into 1. So this gives us this. So we put it here. And then plus c. So when x equals to 0, y also equals to 0. So minus e to the power. So this will be 1 minus 1 equals to 0 minus 1 plus c. So c is also equal to 0. So it will just be minus e to the power minus y x e to the power x minus e to the power x. So now we have to find y in terms of x. E to the power minus y gives e to the power. So minus y is so this is our final answer. Explain briefly why x can only take values less than 1. So I'm just using the calculator ones. Oh, because then 1 minus x will become negative, and so this whole thing becomes negative, and ln of negative is not possible. So we can only take values of x that are above 1. Number 8 we don't have in our syllabus right now, so which has planes in it, so I don't know how to do that, so I'll skip that. So number 9, since we can see down also the highest is x cube and up is x cube, so we have to first divide it and make it smaller. X cube plus 2x, right? So that'll be x cube plus 2x, 3x cube minus 8. Right. So 3 minus 8 by 3x cube plus 6x minus 8. Since it's x squared, it'll be bx plus c. So a into x squared plus 2 plus bx plus c into x equals to 8. X equals 0. Let's x equals 0, so a will be 2 plus 0 equals 8. So a will be 4. I haven't taken the minus into account right now, I'll put it later, so the signs will change then. XB 1 3 plus b plus c gives 8. 3 plus b plus c gives. So now just solve the equations. So minus 4 minus 2c 4, so b is minus 4. So it'll be 3 minus, oh wait, no, this will be plus 8 since the sign changes. So if it's plus 8, right. Wait, am I making a mistake somewhere? 3x cubed plus 6x minus 8, okay. Hmm, 3x cubed plus 6x. 1 second. Oh no, this will be minus 8 only, yeah, sorry. Because we haven't used it yet, so it's just like that, so it'll be minus 8 down. So it's minus 4 by x minus 4x by x squared plus 2. Right. So now the minus goes in, so it becomes minus 4 by x plus 4x by x squared plus 2. So a is actually 3, b is minus 4, and c is 4, d is 0. Part 2. Show that fx dx is 3 minus ln 4. 3 minus, so take it from the previous equation. X squared plus 2. Wait, first integrate it. 1 to 2. So 3x minus 4 ln x plus, that will be oh wait, that's 4x 2x ln x squared plus so differentiation of x squared plus 2 will be 2x, right? So it'll be 2 into ln x squared plus 2. Yeah. So it's 3x minus 4 ln x is 2 ln x squared plus 2, 1 to 2. 3 to the 6 minus 4 ln 2 plus 2 ln 6 minus 3 minus 4 ln 1 is 0 plus 2 ln 3. Two is 4, 4, 4 is 16. 26 minus 3 minus ln 9. So 3 plus ln 36. 16 minus ln 9. So 3 plus 36 by 16 to 9. 9 4s are 4 4s are, giving us 3 plus ln 1 by 4 plus ln 4 to the power minus 1 gives 3 minus ln 4. Hence proved. Last question. So we take z as x minus iy and x plus iy because they are conjugates of each other. So that will be plus. If that's plus, that'll be minus. Now we solve it. I squared is minus 1, so x minus iy plus 1 gives 2ix minus 2y. So x plus 2y since y goes there. Plus 1 gives 2ix minus plus iy. So x plus 2y plus 1 minus 2ix minus iy is 0. So now we separate the real and the imaginary part. So x plus 2y plus 1 equals to 0 and minus 2ix, wait, I minus 2x minus y is 0. So now we can just solve it. Therefore x is 1 by 3 and y is minus 2 by 3. Now we just put it as x plus iy, which is 1 by 3 minus 2 by 3i. So this is your final answer. B part 1. On a sketch of an organ diagram, shade the region whose point represent complex numbers satisfying the inequalities. Okay. So the first inequality is z plus 1 minus 3i is less than equal to 1. So now we substitute z with x plus iy plus 1 minus 3i. Now we separate the real and the imaginary parts. So this is the mod sign. This means that we have to find the distance. So x plus 1 whole square, we use the distance formula, plus y minus 3 whole square root is less than equal to 1. So this whole square can go there and then become 1 square. So this is in the form of the equation of a circle. So the center is minus 1 comma 3 and the radius is 1. So that is one equation. The second was imaginary is greater than 3. So now we can plot it. So this is the real axis and this is the imaginary axis. And now I'm not drawing it to scale, but I'll just give the plottings. So centers minus 1 comma 3, and since the radius is 1, so 1 1 1 1, so that's our circle. Sorry if it's a little not circle like. And imaginary greater than 3, so this is 3, and so above this is accepted. So the shaded region will be this region, since it's all greater than equal to, so it'll be a solid line. So this is the how the sketch will look. So part 2, determine the difference between the greatest and the least values of arcsine for points lying in the region. So the arc value is always calculated from the origin. Part 2. Okay. So we have to find the greatest and least value of arcsine for the point lying in the region. So it'll be from here, you draw a line. This is the greatest value and this will be the least value. So it's basically just this angle. So we can easily calculate that using trigonometry. So that'll be tan x because it's opposite and adjacent, right? So the opposite is the whole diameter. So that is 2 divided by this till the center. This will be 3. So 2 by 3. So x is tan inverse 2 by 3, which is 0.588 radians. That's it. Thank you. Hope it helped.